Hi, welcome to this demonstration of ICEFaces with automated business logic. Geek and Poke here have encountered a problem that started off simple but became much more complex, and they can't find a technology to help them automate their problem. Ajax is probably not the answer. In fact, there is no answer, at least not now, because while there's lots of automation for user interfaces and persistence, there's no automation for the business logic of an application. The trouble is, it's almost half the application, it takes too long, and it's just too hard. You might want to look at existing approaches, like, for example, Ready engines. But they have troubles with performance that are well known. For example, if I want to check the customer's balance, I have to add up all the order amounts, but then to get those I have to add up the item totals. That's a geometric number of reads, and this is right at the core of transaction processing. Furthermore, your business logic wants to enforce the integrity of your database, but Ready engines only work when you call them, so the logic isn't guaranteed. Process engines don't really offer a good solution because they're procedural. So while it's much more attractive, it's still the same if-then-else looping logic that you're writing in Java. Hibernate itself provides some validation capabilities, but they don't provide the critical multi-attribute constraints and multi-table derivations that are required for transaction processing. Let's take an example. Let's look at this customer order and item application and consider the add order where we want to check the credit limit. And as that shows with our cocktail napkin specification, 5 simple rules express exactly what needs to happen with that. Let's have a look at the application for that. Here's an ICEFaces application showing a customer, order, and their line items where the price times the quantity roll up to the total amount and then to the balance. This page is nice because it lets us look at the related use cases besides just add order, because that's often where the work is. So let's have a look at a few. So for example, we could reassign a line item's part and notice how the balance changed. Or we could delete a line item. Or we could come and pay or unpay an order. We could change a line item quantity. Or we could change line item quantity in such a way that we get the expected violation of a constraint. So the application started off with a simple set of requirements, but it got pretty nasty. What we saw in the sample app was a whole bunch of different use cases that I had to analyze. And the trouble is, what if I forget one? Very, very serious database integrity issues. Secondly, I have to do design. Do I write a service layer? Do I write data access object, events? So it's not so simple. And finally, I have to do development, that is, for each of these use cases, detect changes, do propagation to related data, and I have to do optimizations to prune and optimize my SQLs. And I have to do that for each of these use cases, and that's where I get into 500 lines of code where what started with a simple problem. But we keep asking ourselves, golly, the spec was so simple, why wasn't that enough? Well, now it is. Here's an illustration of how you define business logic. Here you have your Hibernate POJOs, like customer, and corresponding to those you build logic classes. Here's the customer logic class. And the first rule is highlighted here. Rules are identified by these annotations. Here's a constraint. That's the first rule of our balance is less than the credit. Here we have our second rule. This is a sum for the customer's balance, where the sum is defined as the purchase orders amount total for the unpaid orders. So notice that business logic enables you to define what your data actually means. And the rules chain. The amount total from the purchase order itself is computed by the sum of the line items amount, where those are computed with line item logic for the price times the quantity, where the price comes from the part. What's amazing is this is all of the logic it takes to do all of the use cases we saw on the prior slide. And we've seen this before. Just as a spreadsheet enables you to define a cell that's the sum of a given column, your spreadsheet understands what it means to change any value in that column, to add a row to the column, to delete a row for the column. In the same way, This customer balance is automatically applied to adding an order, the balance goes up, deleting an order, the balance goes down, paying an order, the balance goes down automatically. Optimizations are also a critical part of automation. This rule here for the customer balance may look like a SQL sum. It's not. In fact, what we do is adjustment logic. If we have an order for $100, we simply access the related customer, possibly in cash, and add 100 to its balance. So that avoids the geometric read problem we spoke of earlier, replacing it with a single row update. Ordering is also automatic. These rules can be entered in any order, and that's important during maintenance, because most of maintenance is the archaeology of looking at the existing logic to figure out where to put the new code. With automatic ordering, that's not any longer necessary. You simply come and change the rules, add them, delete them. They're automatically reordered and executed in the proper order for your next transaction. So how does it work? Well, basically your job is to define the user interface and persistence just as you do now. Your framework or your code itself makes the same existing calls to Hibernate, no changes to those. Our transaction logic engine plugs into Hibernate events like before update, before commit, and so forth. And when it finds them, it finds your rules, runs bytecode analysis to understand the dependencies so that it can execute your logic in a correct and efficient order. It's very easy to get started with business logic. If you're using Hibernate or JPA, you're pretty much there. Just download the product, add one line to a configuration file, and add the same logic files you saw a screen or two ago. Besides optimizations, one of the critical questions to ask about automation is it extensible? How does it deal with complexity? While the example problem we saw was simply dealt with the logic and annotations, you can also specify logic in Java or Groovy methods, thereby extending the engine. Our product ships with examples of such extensions that you can use that can automate a bill of materials with just 5 rules and other equivalently difficult applications that represent the high end of use cases we've seen in decades of experience. So what is it that makes this all work? Well, first of all, it's declarative. That's where we get, when you say what to do, not how to do it, that's what enables the system, in fact obligates the system, to perform optimizations, to execute the logic in a proper order reflecting the dependencies. But what you get is simplicity. In fact, it's so simple that the system becomes transparent. Business users can understand it. So your applications become corporate assets where they can be understood by IT and business users, working together to spot omissions, opportunities, and so forth to reduce requirements risk. Business logic rules are stated on the domain objects, not on a particular use case. That is what enables us to reuse the logic across all of your use cases. And that's what is a major reason why we can replace 500 lines of code with just 5 rules. And finally, we talked about the fact that it's a plug-in architecture. It's easy to get started. It fits right in at runtime. If you have questions about scalability or distributed transactions or what platforms it runs on, those are all answered by where does Hibernate run. Wherever Hibernate runs, you can use business logic. So in summary, the business value from this technology is really agility. If you can do in 5 rules what would otherwise have taken 500 lines, you're being much more adept at responding to business change. And you respond with better quality. Unlike a manual approach where you might get right into final testing and then start discovering use case after use case that forgets particular bits of logic, since the logic is applied automatically to all use cases, even ones we forgot in our earlier slide like reassign order are automatically taken care of. So you get a design one, solve many effect. And finally, a similar challenge that people often see going into production is as they move from development where things run well to production-sized data where things suddenly slow down, it's often these geometric reads. These are engineered away, as we discussed earlier. So thanks. That's a quick introduction to business logic. You can download and get more information from our website. Let us know what you think. Thanks a lot.